Hi guys, hope you can join in today. Thank you very much. I hope we're not experiencing any internet connectivity issues right now. I was seeing a lot of drop frames here, but hopefully it'll be good. If you experience something, please let me know in the chat and I'll see what I can do about it. It may just be one of those days. But yeah, thank you for joining in today. So I hope you have a cup of coffee, you're well situated, and just enjoying your Tuesday so far. We had a session yesterday where we mind map and thought about some topics we could go over in future streams and learn more about together. And today I thought we are going to look at deploying a machine learning model to the .NET Core application. If we have time, we'll also look at doing an Azure function potentially, but we'll see where it takes us. But to start off a bit, I do want to start off some music. Let's see if that works. By Carl Franklin. Alright, got some background music here. Alright, so if you have any questions today, as always, just feel free to ping the chat. I'll try to monitor the best I can and address things. But before we get started, let's just use this tool Miro again to kind of map out what we wanted to achieve. I think that is the best way to learn and to kind of visualize some thoughts we have and put them down somewhere we can see them. So, and I really like Miro, honestly. It's been a good tool to get some of those things out there. Okay. So, what do we want to do today? Well, I want to create a rectangle. Kind of fun, it was the same thing yesterday with this tool. It takes a while to get started. So today we're going to look at deployment scenarios, right? Let's see if he wants to type here. We'll just type it. So deployment. So some ways we can do deployment in this tool is of course integrating it into a web API. So that's something we wanted to explore today and see how we get to. Another way we can do this is also an Azure function. And this serverless option I think is awesome. And will definitely be used, I think, by a lot of companies out there. So that's something, if we have time, we'll also address. And in addition to this, we can also deploy it to a desktop app, but we'll talk about that in a separate session, I think. And we will also talk about Docker containers in a separate session. But today we'll talk about Azure functions and web APIs. Alright, so before we can get to deployment, we do want to talk about how we can build a model. So we can pick an existing model if you like, or we can start just building one from scratch and kind of see where this takes us. And I'm a little bit intrigued to try something new and actually build a model from scratch with y'all using data that I have never seen. This can go really bad or it can go really well. It kind of depends, right? But I want you to appreciate and also follow along in the thought process when we build these kind of models and do it end to end. So I think we'll have a lot of good gains and insight from this process, regardless how it goes. If we somewhere on the line have some struggles with building our model, we'll just pick one that we already have. All right. Hopefully that sounds good. So how would I go about finding data first of all for a model? Because any machine learning model or any problem we have starts with the data. Without the data, we can't really solve a problem. So the way I do that is usually going to Kaggle, and it's an open source machine learning competition platform for these kind of things, and I try to pick a data set that we can use. So let's have a look here, and you can definitely do it yourself if you want to. It's a good way to get started. And let's see, it's gonna change this up a little bit. Okay. So if we look at some of the data sets we have here, go to data, and we have data sets, right? And as you can expect here, there's a lot of COVID data sets to help solve this crisis. We can scroll down and see if you find something here that seems interesting and also reasonable. This could be good, I think. Fake and real news data set. Let's have a look at that. So this data set, I assume it's like a classification challenge to figure out if something is fake or real news. Okay, sounds good. It's a binary classification issue because we have two options, so that's a good place to start. It seems like we have two files as well, where the fake news is in one file and the true news in a different file. So that's going to be good. They can showcase some of the ways we can load those data into memory. So let's go ahead and get this one, I think. So we'll download that. Okay, we got that. Go ahead and extract that. Yeah, we'll put it down, so it's fine. Nice. Alright, so before we get started actually loading this, let's look at the data, and it depends on how large the data is. This kind of size, we could just open an Excel like right now. Anything larger than this looks like it's 60 megabytes. We could definitely have to use something like Jupyter Notebooks or something else to get a good view. And even this is a bit too big, but let's have a look. Oh, that was a bad idea. Double clicking on the text. So we have a title column, we have a text column, we have a subject, and we have a date, right? And it's the fake news. So it looks like different kind of articles here. Alright, sounds good. And we have a pretty good oversight of this without using Jupyter, so I think we'll just do this for now. But one thing we will need, I think, is a column of what we're trying to predict here. And what we end up going to predict here is fake news, I think. So as we're going to use supervised training for this, we need to label this data, and it's separated into two data files right now. There may be a good way to load two different data views and merge them in memory in the file, but what I will do is kind of just label the data instead real quick here. So it's false news, we can call that, right? This is going to be the fake data file, so what we can go ahead to do is add 1 in this column, right? 1, 2, 3, 4, yeah. And we should be able to, can we just extend this? Yeah. Oh, of course it's a CSV file. It's gonna make it a little bit more difficult. Can we do that real easy? I'm gonna Google this to find it real quick. I should of course know this, but I don't on top of my head. That's okay. So if you don't want it to be read-only, change this somewhere. Why is it read-only? Well, I think let's get started building the model for now, and we can try to figure out this problem as we go along instead. Don't want to take too much time on this specific issue here. So what we can do here is open up a new Visual Studio or create a new solution, and we'll kind of just go with the flow here and see what we get us. So a .NET Core console application is generally the best way to create a model for ML.NET. So that's what we're going to do, and we can call this false news model. Okay. I don't want to say my previous work. Okay. Perfect. So we have a general console application here. So when we train a model in ML.NET, there are some steps we need to follow regardless. So we can just kind of we can comment them out here for our own reference. We could of course label this data, and we can run it through something called the model builder, so do automatic machine learning to make this work. But I kind of want to build this model from scratch so we can learn together and get this repetitive effort in here. So the first thing you have to do when we create a model is load into memory. So we need the data into memory. The second thing we need to do is split the data really in trading and test data set. We then need to transform the columns. So in our data sets we're going to have text column, so we need to make sure they are transformed to numeric values. After we transform it, we need to train our model, and we then need to evaluate it. And finally we need to save the model to a zip file, because that's the one we're going to use later, right? For loading into an Azure function or an ASP.NET Core application. So when we get started here, the first thing we want to do is install the ML.NET library. You can do that through your NuGet feed if you want to, or you can just do it here. I'll just do it here. So install package Microsoft.ml. That's going to be the main package we want to install. Enter there. And we should get some things here. Okay. Dependencies. I should have a package here. Perfect. So based on that, what we do first is creating an ML context. So ML context is kind of the holder of the all methods. I need another spell here. Like that, right? So the ML context, if you just drill into it real quick here, we'll just look at the definition for now. We'll see different catalogs. So we'll see binary classification, which is the one we're going to use, multi-classification, regression, clustering, and different things. So a catalog for each type of machine learning task we want to do. And depending on your problem, you want to dive into each of these, and you'll find trainers, so algorithms, and evaluation metrics and methods in each of these. But we'll just create one like this for now to be able to access these methods. And a little trick here that we need to do as well is to set the seed to a value, any value. 1 is fine. And the seed here makes sure we have deterministic randomness. And it sounds really complicated, but we'll see why it's important. But in general, think of it as a way as if we run this console application again and again, and to retrain the model, we don't want we don't want the performance of the model to change just because we retrained it. And that has to do with the splits of the test and the trained data. So setting a random seed that is determined will achieve that deterministic randomness. So bear with me, we'll kind of go back to that concept in a bit, but you can just set it to a number all the time here. Alright, so then we need to load into memory. So we need to load the data into memory. And if you look at the data again, let's open up one here. Let's see, takes a little minute. We'll see that we have these columns, and I would assume that the title and the text are important. We can probably skip the subject and date for now, honestly, but we do need to create a schema for the data, so we load it to memory. So let's create a class for title and text here. So we'll call this class here. Control-Shift-A helps here, and news input, because naming it is hard, right? Alright, and this news input should have two properties. The first one, let's see, the first one should be a string. We'll call it title. The second one also being a string, let's call that I guess text is fine, because that's what it is. And a trick here as well, if I don't forget or remember correctly, is that we need to define the index of these columns. So I think it's called load column and 0. And this is the index in the file we're loading. So 0 being the first column, right? So title is the first here, so 0, and text is second, so that will be 1 given a 0-based index here. Nice. So we have the schema defined, so we should be able to load this into memory. So let's call this data here. And on the ML context, we can then access the data and load from text file, right? And we'll use the generic version here, because in the generic version, we can actually define the schema that we have. So news input. And we need to define the location of the file, and in this case we want to kind of go back to this, but I'm going to do this, and I'm gonna, hopefully we can load multiple files here in a bit. And that looks horrible, but that works. And we need to be able to find the separator character here. So is it a comma separator or a tab separator file? In our case, it's a comma separator file. And we also need to define things like, does it have headers? Should we read the first row? In our case, that is true. Okay. Perfect. And let's go back here. So again, if you have any questions on the chat, feel free to ask them. I'm happy to try to answer them. Otherwise, I'll continue working on this problem together with you all. So the issue we have right now is that we need to label our data before we go any further. So we will need to add a 1 to this one and a 0 to the other one. And I think it's not read-only anymore. Not sure why. Did I accidentally go to the zipped folder before? Not sure. Let's try to add this false news here. Okay. If I save this, are you going to save as well? Okay. Let's open it up again to see if it actually worked. I want to make sure I'm on the right location here. Okay, that was probably the wrong location. Let's try that one. Okay, there's it. I think this saved it. Let's try. Let's see. Yeah, perfect. Okay, so let's do that for the true one as well. So let's label true one. And if you like what you're seeing or want to learn more and kind of keep you up to date when I stream, please go ahead and follow this channel, and that way you get notification when I'm online. You can choose to tune in or not. Okay, so here is not fake news, so we'll go ahead and do that. Perfect. Save that file. Awesome. Wow, that was actually not too bad. And let's just make sure we're in the right location by copying it again. Perfect. Alright, so if I run this now, and I actually should, to make sure we don't break anything yet, I should be able to have some data in memory here. And it's lazy loaded, so it won't really load until I execute anything, but let's just see how it looks. So if I press F5 here, we get a console up here. It's like any console application. Put a breakpoint here actually. Okay, we went past it already. So we can hover over this. We'll see we have a data view. We have a schema, right? And we should be able to get the rows as well once I execute this. Perfect. So let's continue and see if we have any issues. But one thing I wanted to add as well now is the predicted value here. So we added a new column called is fake news, and this is the one we're going to use to both train our model but also have as a predictor for future reference. So in machine learning we call that the label, and it's going to be 0, 1, 2, 3, 4. So index 4, right? Yep, is false news. So let's add that. It's going to be prop bool is false news load column 4. So when we load this, we're also going to load this information, which is going to be useful for other things. Nice. Alright, so once we have the data into memory, we need to split it into a training and a test data set. And we can do that using a built-in method in the ML.NET, and I think it's under data. If not, you can always go and look. Okay, train test splits, that's what it's called. You call it, you pass in the data, and you can see here that we can have multiple overloads. So we can define the split if you want to, being 10%, 20%, 30%, whatever you like. Usually the default is pretty good, so I'm going to leave it at the default here. And what this will do is it will give me an object with two properties, and we can just split it up for fun here. So test data, test train set, test. So that's going to give me 10% of the data set randomly that is going to be used for test sets, so we can evaluate our model afterwards. And train data, of course, is the 90% remaining that's going to be used for training the model. Cool. So now we move into the more machine learning stuff, because so far we only loaded the data and we played around with it. So what we want to do? Well, we want to probably create a transformation pipeline here, and the reason for that is because we want to transform the title and the text to numeric values. And to do so, we need to create a data processing pipeline. I call it that. It's just let's call it a data pipeline. anything in ML.NET really is a pipeline. We chain commands to each other, we just change functions. It's like C# chaining, right? Method chaining. It's nothing too advanced there, but each method on the chain does something specific. The first ones here are going to transform the data in some way or shape, so that the algorithm further down the chain actually can use that data. And then we're gonna append a trainer into that method chain to fit that transformed data to our output or our labels. And eventually we're gonna also evaluate it and make sure it's a reasonable model. So in this way, I think on the ML context, we should have a transform. And I think we need to do text maybe. Featurize text. Okay, so we probably want to featurize the text here, and what that means is that we're taking a chunk of text and we're turning it to numbers. I mean, there's a lot of things underneath the surface here, and we can talk about that if you like, but really you don't really need to know that. You just need to know that this is a way to transform text to something a model can understand. And we are giving the input and output column names here, so I usually like just doing name of news input, and we'll do let's do title first, and then to that we want to append the next thing. Append, and we want to do the same kind of transformation for the text column. So again, ML context, transforms, text, featurize, text, name of, news, inputs, text. And you can just use a magic string here if you want to, and just say quotes text or quotes title. That works fine too. I just kind of like not having them around if I don't have to, so this is kind of a little bit easier. Okay, and then we need to append the creation of this feature vector. And the way we do that is, I think it's concatenate features, we'll call it features, and we are going to just copy paste these two here. Okay, and what it's doing here is just saying, please go ahead and create a features vector based on these two columns, and kind of spanning up multi-dimensional space here. So that's awesome. Okay, and we can do more things here. We can normalize these if you want to. We can do some other stuff, but let's see if this just gives us the bare metal here, because we just want to get this working somewhat. Okay, so let's assume we have a pipeline that works here, and I may have missed something, but we'll go back to that in case. Let's create a model, or train a model here. We do so by appending a trainer. So let's call it a training pipeline. And we'll take the data pipeline, append, and we'll pass in some fun stuff here. In our case, ML context. Let's see, remember this. Okay, so what we're doing is binary classification, right? We're trying to determine if it's false news or not false news. So you will find the trainers, algorithms, and all the evaluation things under here. So let's probably take a simple one here. Trainers, regression. So I like to start with this one. It's a simple one, logistic regression. It's not really regression, it's used for classification, but it's a good starting method when we talk about classification tasks. So let's try this one. And let's see, what is it taking? Well, it's taking the label column name. So that's the name of the answer, the thing we're trying to predict, right? In our case, that's going to be it's false news. So we'll do name of news input is false news. Perfect. Let's see, does it take anything else? Okay, and by default here you see that the feature column name, so the combination of those two text vectors, is features, and that's why I named it features up here on line 23. And I'm gonna leave it like that because I think that should be fine. So we'll stop there. Okay, so the trainer model here, this is where the magic comes in. So hard. We'll take training pipeline, call fit, pass in our train data, and that's it. You're gonna get your training model right here. And you can see here that if we debug this, this is gonna be really quick, this is gonna be really quick, and this is going to take a long time, or longer. We have 100 megabytes, and it will take a little while, but everything else here is lazy loaded and doesn't execute until we actually get down here. So we'll look at it a bit later. But now we're gonna have a training model, and let's evaluate and see if that's something we want to do or not do. Okay, so let's see. What we want to do here is we want to get metrics on the model, and when we talk about binary classification, we generally want something like let's see, we want F1 score, of course, precision and recall, and accuracy. Accuracy is a good one, right? Accuracy means out of these ones that are predicted, how many were actually predicted accurately, like 90%, 95%. And it's a good measurement if your data is balanced. So in our case, if we have equal amount of false and or positive and negative cases, so true and fake news and not fake news. I don't know right now our distribution, so it could be good, could be bad. The precision and recall are better measurements in general because they measure how many false positives we have and how many false negatives we have. And the F1 score, it's a harmonic mean between both of those. So if you get a value close to 1, then that's a better value than something closer to 0. So we want something close to 1 there. So just some information before we start doing this. But to get this, we generally need 2 lines of codes, and the first one I think being predictions. We want to take the train model, we want to call transform, and we want to pass in the test data. And by doing that, we are actually getting the predictions on our model on the test data, as well as the probability that this is correct. So for example, it's going to take a text from a fake news, it's going to say, yep, this is fake news, with a probability of 60% or 80%, depending on how certain it is. So we'll get that nice predictions here. We can take those predictions and we can calculate based on that how good the model is. More or less, first of all, did it get everything correct? And the ones that it got correct, how certain are they that they actually got it correct? And those who were false, how far away from the true value are there? So we'll get that kind of nice metrics to understand the model better. So we'll call it metrics. And let's see, I think that's on an ML context, binary classification, evaluate. Alright, perfect. So you'll see that we have the evaluation method under the trainer for your specific ML task as well. And if we look at this, what we want to pass in here is the predictions. It's going to be the name of the label column, which again is name of news input is false news. And I think that is it. I think we'll be good with that. Cool. Alright. So I'm going to do the last step before we run this, because it may take a while to run. I don't want to run it again if I don't have to. So the last part here is to save the model to a zip file, right? And so we can use it and when we deploy it, which is kind of what we want to achieve today. We want to be able to deploy it. What you do then is you call ML context save, no, model, and you'll see quite a few options here. Load, which we will use later when we get it from the zip file, and save, which we'll use right now. So if you call save, all we need to pass in, of course, is the model we're going to save. We need to pass in the schema, and I think we can get it from the train data schema. Yep. And of course the file path. And we'll just save this next to the solution. And let's call it something more better than ML model. Let's call it fake news predictor. .zip. Very fancy. All right, so we may have something that works here, or we may not. Again, I haven't seen this data before you have, and I have not played around with it, so I don't know. But we're gonna put some breakpoints here. Let's be bold and kind of see where it goes. So if we press F5 here, let's see if it breaks somewhere, because it definitely can and probably will. Okay. We have a pipeline here, right? Let's see if it breaks here. So far it's thinking, which is a good sign. So I'm not sure how long it's going to take, because sometimes when I stream it takes a bit longer. And it broke. Let's see. Could not parse value I want to wish all of my friends in line to column. It's kind of a fun message. But yep, okay, so column is false news. So what is the issue here? Oh, okay. I want to wish all my friends in line 2. That's an interesting issue. I think that's probably the text in one of the files. On line 2, column is false news. So I wonder if it's an index issue here. So let's look at the data real quick here to see if we can figure out what's going on. And this is generally the process when we do these things, right? We build something, it breaks, we try to figure out the issue, and hopefully we'll solve it. And if we don't, we have still learned something valuable. Okay, it's searching. Couldn't find it in the fake news. Let's look for it in the true values here. Opening up. Okay, can't find that. So, or is there something off here? We have those. Sometimes the CSV file itself could be difficult to read. So let's open up in Visual Studio Code to look at it better and see if there's anything issues. I definitely run into issues sometimes where Excel can read it, but we can't load it in ml.net. So this may be one of those cases, and in that case we'll kind of skip it. So opening up here, yeah, I think this may be one of those cases. So the issue right here is going to be line breaks, probably because of the text values here. So that's not very good. Okay, let's see if the model builder can handle this data, and if it can't, then we'll resort to an existing model that we already have. And to do that, I think what I want to do is create a file that has both the true and the fake data. So I will bring it here to see what I do. I'm going to create a new file call it combined. And let's open the fake data and copy it into the combined value, which contains the true values so far. Okay, we got the fake up. Let's also open the combined. Okay, combined is there. I wonder if I can do. Nope. How much data do we have here? Can I do this? This is probably the best way to do this, but I'm going to try anyway. Okay, can I do this? Combined. Nope. Okay. Well, this is fun. Doesn't always work out the way you want, right? Actually, let me see this instead. Okay. Actually, before we even spend more time doing this, let's see if the model builder can even handle this data. So you can do that by add a machine learning, and we'll take you to the model builder. In our case, we'll just pick custom scenario, because I want to see if we can read the file. Because I think something is off here. Downloads, fake and real. Let's pick the fake one. Okay. I like this though. Last time I tried something like this, it just exploded in my face because of that locked process message, and I was not told. And that seems to be fixed. So awesome! Very happy about that. Super helpful, especially when you get started with this. You can get some messages of what's wrong. It's not always obvious that you have a file open. Okay, so you see, this is the issue we're running into here, and I've seen this before. So we have, even though it's a CSV file, the library can't read this file by some reason. If anyone on the MLNet team watches this stream, definitely please look into this. I'm going to report an issue actually in this one if possible when we do this. Because this one should be possible, right? So you can do that on the machine learning library here. So let's do bug report. We'll say unable to read CSV file from Kaggle. Perfect. Attempted to use a CSV file from Kaggle, and let's copy this in once, this here, so it would help. Got a message saying that the format was incorrect, although applications such as Excel can read it. Okay. And let's copy paste maybe in a picture of that warning message as well. So if you run into any of these issues, I really encourage you to report it, because I had an issue again with open files sometimes, and it's always been fixed. So if you report it, the team will have a chance to do something about it as well. But if you don't, they won't know about it. Okay, I would like to be able to use the CSV file. Okay, perfect. I think that's good. Okay. Hopefully that's helpful. Okay, so given that, I think there's no point to continue to build this model. So instead, let's change the data set and use something else. And just for simplicity's sake here, let's use Titanic data set. And I think I've already shown you a lot about, let's see, how we would build and model these. So all these steps hold true regardless. It's just that right now the data we have is in malformat shape, and there's ways to fix this. I've done it on previous sets, but it's not really the topic of this stream today, so I'm not going to go down this rabbit hole too long. But instead, what we can do is use, for example, the Titanic data set and use the model builder to create a model for us, so we can deploy it to an application, which is what we want to do. So let's create a new solution here. Project. Let's call this Titanic model. Very good name. And the way to do this again is right click on this project, press add, and machine learning, and you'll get this option if you enable it under your options in extensions, I believe, if you have the latest version of Visual Studio. If you don't, this is going to be extension you can install. So perfect. So we'll do custom scenario, we'll pick a file, and I think I have that data set here somewhere. Maybe Git, because I have a repo with it. Titanic. Yeah, I think this is it. Okay. If we peek on that, you will see that we have some columns for survived, passenger class, name, sex, age, those kind of things, right? And what you want to do here is select the column we want to predict. So we want to predict if they survived or not, right? And let's skip these columns for the prediction. We'll just keep it simple here. Passenger class, name, the gender, age, and the fare. And I think we can skip the fare as well because it's kind of correlated with the passenger class, right? Oop. It's not going to have any more predictive power or account for any of the variants. Alright, and we see here we have a missing value, so hopefully the tool will handle that for us, which is cool. So let's train this. It is a very small data set, so 10 seconds should be good, but let's give it 20. So what it's doing here, reading the data, and it's going over different permutations for this model to make sure that we'll find one that is accurate and that can serve as well. So I hope you're all enjoying your day so far and enjoying what you're seeing. If you have any questions again, please go ahead and put them in the chat or just DM me on Twitter. I'm happy to try to help. And if you haven't already as well, you should also tune in to the virtual ML.NET community conference that is at the end of May. You can register yourself already right now to make sure you get all the updates. There's going to be a workshop and there's going to be sessions from the community. Okay, so we have a model, we can evaluate that, but we don't really care. Instead we want to add projects, and what we end up getting here is 2 projects for the machine learning model. But I really want this zip file right here because that's what we're going to use when we create our web app. Okay, so we have a model, perfect, and we can see that it's 80% accurate, which is good for this data set. And again, I talked about F1 score earlier, remember F1 score was the harmonic mean between two values called regression and precision. And we don't need to know too much about what they really mean, but you want the value as close to 1 as possible. So you get the music going. So 0.72, so 72% is a decent value. It will give us somewhat an accurate model. Okay, so let's try to create a simple web app here, a web API for simplicity's sake, and see how we would go about deploying this and actually calling it from, let's say, Postman or something else. So first thing we do, of course, is create a new ASP.NET Core application. I think this one should be good, right? C#. We call it Titanic Predictor. Okay. We don't really need to save it, honestly. It's fine. I think I have one if we need it to as well. Okay, and we'll pick an API project style here for this case. Perfect. Okay, so what do we need to do here? Let's see. Well, first of all, we need to be able to have an API method to call. So we have, of course, a weather forecast, something here, controller. So let's create an API controller which we can call here for our service. So I think you can do this. Controller class. Let's call it Titanic Predictor controller, because naming is hard again. And that's good. Let's see, we need to copy stuff from stuff here, I think. And the route's not good. Well, that's fine. Okay, so we need a post here. So let's call this predict. Don't press caps lock. Okay, post. I'm gonna peek a bit because I'm lazy right now. Okay. And just pass back a bool here because we want to know if it survived or not, right? So what are we gonna do here? Well, we need to define the input schema here, just as we did previously. So let's make it very simple for us. Let's create a folder here. It's called models, and one of the models is going to be a passenger. And that's going to hold the view model. Actually, let's be even a bit better with naming. Let's call it passenger view model. Yeah, I think that's fine. It's gonna be interesting to see if this works, but why not? And let's go and look and just copy paste. So in general, this is going to be holding properties for each of the things our model needs to predict survived or not survived. We already had this, the AutoML model builder created for us. So let's look at that project just to kind of save some time here. So if we go to where that would be, and hopefully it's saved, honestly, but I think it should be here, under your user, sources, because this is where I created these things. That's the controller objects. Okay, perfect. Let's just open this up again so we can look at it. Hopefully it won't open in 2017, but I think it will because I haven't removed that. No, 2019, nice. Okay, this would be good. We can copy and paste some code there. Okay, that is horrible because there's nothing. Sorry, wrong project. I think I want this one. Oh, this is the model. We want that one, but not right now. Okay, model inputs. Let's just open it up and Visual Studio Code. Open code. Because it's faster. Okay. Please come over here, because otherwise no one will see you. So we have these columns, right? And we don't need all of them, because we're not going to use all of them. But we'll copy them over regardless. Into our passenger view model. And I think we removed fare and siblings and all those kind of things, so we're going to remove those. But we had survived, passenger class, those kind of things. Okay. As you can see, we are missing dependencies. So control dot if you don't use a sharper. And that's, so I was hoping I would get install Elmo.net here, but I didn't. So let's just do that. Because of course we need the framework and the library here as well to be able to do what we want to do. So install package Microsoft ML. Okay. So that's pulling the package down, installing that. Got that. So control dot this time should be able to give me the namespace suggestions. It did. Okay. I don't actually think we need a column and name and load column right now, but I'm gonna keep them because I want to make sure this works. And then we can try to remove them. Cool. All right. So if we go to the controller here, we can now pass in passenger view model, and we can do some fun stuff here. And right now we just return true. And let's see if we can get the API methods for this one. Let's give this a route. I wonder if it's this. It was a while ago since I did this. Let's open Postman. Let's kick this off just to make sure we have connectivity before we go any further. The build succeeded, so that's good. Okay, localhost. Postman is opening on the other screen here. We'll pull that in once it's good to go. It's preparing my workspace, of course. Okay. Come on. Come on over. Join the party. Okay, so we have that open. And the API works, of course, for the general stuff. That's good. Okay, create a new one. Let's do quest. I don't want to do that. Okay, so this is going to be a post. It's going to go here, and it's going to go to the controller name here. So Titanic Predictor, and hopefully it's going to touch predict. And the body here is going to be, in our case here, let's see if I can get this open. It's going to be the view model, of course. So survived, survived. Actually, we can skip that because that's going to be what we want to predict, right? It's going to be P class, so passenger class. P class. Let's say we are 3. This could be a name. My name is Alex. It's going to be the sex, so I think it's listed like male, female, but we should probably look. case, it would be here. So it would be -ml model.zip, and based on that we could create a prediction engine. And I think this is how you do it, or maybe it's actually on the ML context. I think so. And it would be view model, sorry, it would be passenger view model, and it would be the output type here. So let's copy that in as well. That will be model output we are looking for here. So if you open that with code, we want a class something like this. So let's create that. And again, this is not the right way to do it, but I wanted to show you the idea behind this. Let's just call it model output. We still need these schemas regardless. So that would be something like that. Okay. I'm not sure what it's complaining about. Okay, it's running this way. So we would do something like that, and it would be model output. And let's collapse this so we see a bit more. And I think it would be model to spell. And the schema, can I do this? Can't remember which way we're gonna do this. Data view schema. Can I discard this one? Nope. Let's think about that a bit. Where would I get the schema? I actually forgot. So let's look at that. Okay, it's just an out variable. I wouldn't get it anywhere. Okay. And is this also an out variable, or is this actually passing in here? Okay, so we will create a prediction engine, and what we'll do here is get a prediction by calling the prediction engine, call predict, pass in the view model, and that will give us a prediction, which is the same schema as the model output right here. And what we will do then is just call prediction. That's a bad name, but that would eventually get us the boolean we want, and if we type return, we'll eventually get what we want. So let's try to build this and see if this works in theory. So in theory it should work. In practice it may not. Okay, it builds. Let's run that real quick. Starting up that API. Can hit this one already, I think. Wait for it to go through. Alright, so let's see if this breaks or not. Okay, it loaded the model. Okay, so we want the schema to be the same even though we didn't use it, and that's okay. honestly, I would like the schema not to have been dependent on these. So we did was create this model using AutoML, and even though we selected these columns not to be part of the schema, it still wants those. So that's actually an improvement I would like to see. But for now, we'll just pass them in. That's good. Nice. Build that. Let's kick it off. Okay. So if we kick this off, we can load the model. Get a prediction. And actually let's just press F5. And we'll see that I would not have survived in this class. So that's good. So yes, you can do this and it works. But let's try it again just to show something. Some issues we have right here is that it takes a bit to load a model, and the larger it is, the longer it takes, and it's going to eat up memory and performance. It's also an issue in a web app because it's not thread safe. So the ML context, the